Hi, this is going to be a quick video on how to set up a new Galaxy in System Platform 2017 Update 1 and connect to a PLC for auto assignment of variable attributes or object attributes. So to start off with, this is a System Platform 2017 Update 1 machine running Windows 10. Our PLC is going to be a Siemens 1500 series, and the PLC already has code in it. I'm sorry I don't have the software on this machine to show you what's in there, but you'll just have to take my word for it. The PLC's IP address 169.254.25.201. Inside the PLC we have a structure defined that contains a dummy version of a simple S95 style system architecture. So we have in the S95 model an enterprise site, plant area, work unit and work center. In our case, the object hierarchy in the PLC structure is going to be the plant area, work center and work unit. In this specific case, the PLC contains tags that look roughly like the following: plant 1, plant area 01 and 02. In plant area 01 there is work unit 01 containing work center 01, 02, 03 and work unit 02, so on and so forth. So this nested hierarchy allows you to create a very object orientated model that we're going to use for auto assignment of attribute values from the PLC. So without further ado, and you'll have to forgive me if there are little obstacles and things here, I'll try and show you everything I can, and if there are problems that I have to sort out along the way, I'll try and include those as best I can. If anything takes a very long amount of time, I'll pause the video so that you don't have to sit there and watch the cursor going around. Hopefully this is relatively seamless, but this is completely unrehearsed, as no doubt you're going to see in a moment. Okie dokie, so there's probably two major steps that we're going to need to accomplish first. One is going to be allowing the OI operations integration suite to talk to the PLC and then connecting the system platform objects that we create to the OI server. So let's start off with the OI side of things. The IP address of the PLC is here, so we'll just throw that in the clipboard for the time being. So we're going to need these pieces of software: the System Management Console and the Orchestra IDE. The System Management Console is where we're going to begin with, so Operations Integration Server, and we'll leave this under the default group for the time being. And like I said earlier, this is going to be a Siemens 1500 series PLC, one of the little baby ones. The exact model is, it's an ET200 SP and the CPU is a CPU 1510 SP F-1PN. These little things are quite cheap and very easy to program. They're quite good. So let's go into our default Siemens SI Direct configuration. So we're going to right click here and add a TCP IP port. Let's just call it port for the time being. We are going to add symbolic connections. Now this PLC supports symbolic naming, addressing. So if you're familiar with the Allen Bradley, for example, you'll find the compact logics and control logics symbolic or named addressing, as opposed to the earlier SLCs and so on that have the table-based addressing. So table-based addressing is much sort of older-fashioned. Please forgive me, I didn't realize the video editor stops at 5-minute intervals. We will join them all together later. So we paste our clipboarded IP address in here, and we're going to test the connection to make sure that we're on the correct network and everything else inside this virtual machine. So we have a successful connection to that PLC. Device groups, you could think of these as scan topics. Fast. Let's say this is going to be our fast polling topic at 0.4 of a second, and let's create a slow one as well. Let's say 2.5 seconds. These are just arbitrary figures that I'm that I'm just pulling out of thin air. I would suggest, however, that if you're going to make user interactions, anything over about 0.3 of a second is going to feel clunky. So assign things that are going to require user input to relatively fast scanning rates. Otherwise the users will feel, even if the overall system is very responsive, that their interactions with it are slow, and it will make the system feel poor. Just a sort of a UI kind of hint there. Device groups, this is a section where you can specifically map manually selected tags to manually selected names. You could also use this, if we weren't using symbolic naming, as a method for mapping table-based addresses to symbolic names, for example. Okie dokie, let's save that. And let's give this a better name. So this is going to be benchtop PLC, so let's call it bench 001. Okie dokie. I think that'll probably just about do us, so let's activate that driver. Or that server. Obviously you're going to need development licenses and so on. You'll have to talk to your Schneider Electric representative about getting that kind of stuff. If you do not have licenses, the most obvious place to see that is going to be inside your logs here. You'll probably find messages, excuse the state of that, you'll probably find messages in here that indicate that you do not have a license. So license feature DA server, blah blah. So if you don't have a license for this, you'll see that in here. Okay, so we've got an OI configuration that looks passable. So let us move on into Orchestra. Alrighty, we're going to want a new galaxy. This is the name of the local machine, and demo gal. Let's call it that. And let's say it's going to be based on the default. Why not? So this will take a couple of seconds. This is a relatively quick laptop. This is an i7 with 32 gigs of RAM and an SSD, so this doesn't take a huge amount of time. So we'll leave the video running for this, maybe. I would estimate this takes somewhere in the order of 60 seconds. Actually, let's not waste that 60 seconds. I'll pause for a moment. We're almost... I'll close that file just to get it out of the way. Maybe I spoke too soon. Okie dokie, that did add up to about 1.5 minutes. Alright, let's connect to our demo galaxy. One thing to keep in mind is you'll need to undeploy any galaxy that already exists in order to deploy a new one. So given that this is a development machine I've been using, I did that prior to starting the video. So if you create a new galaxy on a machine that's already being used for something else, you'll find that you're unable to deploy to the same machine unless you remove the existing galaxy. Alright. So in here, we have our template section up the top and our model section. So in terms of a general overview, deployment describes where an object is deployed to in terms of machines or engines. Derivation is used to show which objects derive from which class templates and so on. So it shows you your logical hierarchy of your design, and the model view shows you the implementation of those models against your physical plant structure. So think of the model as being your model of your physical plant, deployment being where the software is deployed to, and the derivation is how the software is designed in terms of which things are children of which other things. So let's break this down by expanding them. The star key in this case allows you to expand that tree all the way out in one hit. Don't do it on really big big deployments because it's quite slow if you've got 1 million objects. But in our case it's relatively quick because we've got a very small galaxy. I say that and then it proves me wrong. Okay. So in a lot of ways I'm making this up as I go along, so you'll have to forgive any sort of stumbles with how this all fits together. Okay, so much like our text document, we see here our enterprise, site, plant area. Some of these objects are obviously from the empty galaxy. We're going to change this a little bit. So if we go back to our text document, you'll notice that here I had these two separate, the enterprise and the site. Now they still exist in my PLC, but my nested structure is going to be at the default level of a plant rather than at the enterprise or site level, because I'm going to have different I/O devices for each plant. So in the case of this demonstration, we'll think of it as each building has its own PLC, for example. So let's close this again for a second. So I'm going to remove the plant area and the plant and create those as objects that are derived from a different template. So the enterprise and the site for this application, it is not essential for us to delve into what's inside those. For the demonstration, our attributes that we're going to map automatically don't exist in those. So one of the things we are going to need is we're going to need to create an object that talks to our OI server. Okay, I'll explain why that can't be deleted in a few minutes. So first up, let's go to our derivation view. We're going to derive an object from our master DDE SuiteLink client. So in this case, we're going to derive an instance because we're not going to define a new template in this situation. So let's call it bench 001, the same name that we gave the topic inside the system management console. So we notice the red X tells us something's not right with this object. Obviously this video assumes you're not overly familiar with Orchestra and with System Platform. It's very much an introductory kind of view to things. Obviously if you're familiar with this software, you're going to understand what these things like the ticks and the crosses mean. So as a quick overview, squares mean an undeployed object. A square with a diagonal stripe through it, black and yellow, indicates an object that has been deployed but has been changed since, so the deployed version is not the current version. The little red tick indicates that the object is currently checked out and being edited. Other notable conventions are the $sign indicates that this is a template and it can't be instantiated as that version. You have to instantiate and how do I word this? This is the class definition. This is the description of how the object looks. If we wish to have an instance of it, we have to derive from that object. So the properties of this description in the template are what are inherited by the instances themselves. So like we saw before, this machine is actually called Ent Console. So we're going to use that as the node name. The server name is going to be the name that we created in here. So it is going to be, I believe, bench 001. So that's not actually correct. Let's have a quick look back at this. It is the name of the instance of the OI server. So in this case, it is SIDIR. The postfix of 1 is the instance. That's not necessary for the configuration inside Orchestra, and neither is the prefix here of OI. So we'll go ahead and put in here SIDIR, and we also need the name of the topic that we created underneath that object. So in our case, if we browse back to the System Management Console, we open this up and we look in here, inside the configuration, we have a port. Inside the port, we have our description, and our device groups or topics, scan topics, symbolic fast, which I spelled incorrectly. So let's have an edit of that first. Oops, we have to be offline to do that. So look at that, no pre-planned video. Okay, for some reason I cannot shut down this instance of the driver. So we'll play around with that for a little while. Let's close the IDE. And we'll save the changes for that, even though we know it's not going to be a complete configuration, so there are still some errors. We have to check that object back in and make the red tick disappear. There we go. Okay, so let's go back up here and let's refresh this if we can. No, we can't. Let's go back down to here and attempt to shut down the driver. We still can't do it. Okay, let's close SMC and reopen it and try again. These products, despite being relatively long in the tooth in development terms, still have little foibles that are a little difficult to understand the exact sequence of events that things occur in. Now we can deactivate it. Okay, so if we deactivate that driver, we should now be allowed to configure things that we had in here before that were unavailable to us. Okay, symbolic, spelled correctly, or at least consistently. Let's put that in the clipboard for argument's sake. We'll save this, and restart the driver. If you see a light coloured green triangle here, it indicates that your driver is running in demo mode. Possibly your license is invalid or you only have a demonstration license. So open our Galaxy back up. Make sure I'm still recording. And connect to our demo Galaxy. Okay, that platform took about 2.5 minutes to deploy, and it's now done. What you will notice is the view engine takes some considerable time to refresh after it's deployed, somewhere in the order of 2 minutes as well. So now if we open this up, we can go View in Object Viewer. So let's have a little look here. Connection status, connected. So that's good news for us. So the object viewer is going to be the place that you start to look for most of your debugging information when it comes to individual tags or connections or other issues. One thing I would recommend is if you're using a machine that allows multiple logins or you're capable of logging in multiple users into your IDE environment, do not leave this open on multiple logins. It chews huge amounts of system resources and can actually bring the machines to their knees. As well as the log viewers. That's another tool that integrates with System Platform that causes significant load when multiple instances are opened. Okie dokie, let's have a look at our Derivation View. So this is where we're going to start to describe our model. And our model is going to match up again with this. So we're going to need a plant area, work unit and work center. All of this model exists already in the PLC, but we're going to need objects that represent our physical plant. So let's take a user-defined object, and in order to have some properties, some attributes that our instances inherit, let's define those right up at the top of the hierarchy. So our user-defined objects are all going to inherit these properties, and for simplicity's sake we'll keep this relatively short. Let's have an S95 name. It's going to be a string, and it's going to be from I/O. So we will leave this completely alone for the time being, and I'll explain what that does in just a moment. So additional to that object, it's going to have an S95 description. This is also a string, and it is going to come from I/O. And we'll leave that alone as well. We'll check this master user-defined object back in. Now, any object that instantiates a version of this or is another template derived from this will contain those inherited properties. So in our case, we're going to make another template. This is going to be a template for our plant. So let's name it plant. We're going to also need another derived template for plant area. Try not to use underscores just because I don't like it. Plant area. Let's have a work unit. And finally, a work center. And I think in saying that, I've led you slightly down the garden path here. These should be reversed. This should in fact be work center, and these should be work units. So each unit belongs to the work center. So for example, you could have the plant located at your processing facility. The plant area could be the product in feed section, and then the work center could be conveyor system 1, and then the work units could be conveyor system 1, segment 2, segment 3, and underneath the work units themselves you might have individual motors, proxes, and so on. Let's go back to our model. Now we have some templates derived from the master user derived template. Inside these we should have those inherited attributes that we defined in the parent object here. So they're grayed out because we can't edit them in this instance because they belong to another one. They are inherited from the parent up here. Okie dokie. Now we're going to need individual instances of these. So let's create an instance. Okay, so we've created a new instance and it's been given the default name. We're going to change that name to plant 01 or P01 in order to reflect more accurately what's inside the PLC. The orange square indicating, of course, that it's not deployed. So, as per our text document before, we have a plant area called PA01. So again, these look like this: P0, PA01, and so on. So we're going to need a work center. In fact, we're going to need a few work centers. Let's call these work center 01. Work center 02. And we're going to need a couple of work units as well. Work unit 01. Unit 02. Now those of you who are more familiar with System Platform are going to see a problem here straight away. We need to have unique naming for all of these instances of objects. Now earlier I said that we were having our plant as our highest level in our model, and that's because the PLC is unique to the plant. So we don't need any uniqueness past this level. We do, however, need uniqueness here, here, and further down. So we're going to have to name these objects just a little bit differently. So let's rename this one P01 underscore P area 01. Now I would do this all in one hit, but there's a reason I haven't, and you'll see that in just one moment, and this is to do with the way that we link our objects together. and we place them under each other. So what we will do is put this back to its original name for just 1 second, PA01, and now we're going to start setting up how our model looks. So when we link these together and set their contained names, we're starting to set the hierarchy of these objects. So we have a plant area that belongs to plant 01. Now we have work centres that belong to that plant area. And now we start to see the naming hierarchy form. So each one of these work units is going to belong to, in our case, work centre 01. So now we have a full contained name hierarchy that is going to describe the model internal to the PLC and its nested structures. Now, because we wanted that uniqueness, let's go ahead and rename those objects now. Had we have renamed them earlier, we would have to rename the contained name each time. This way just feels slightly neater. So we go F2, and do P01, PA01. Copy that to the clipboard for the next one. And I'm hitting F2 to do this, obviously. Now I'm going to copy this. Work unit 01. Work unit 01. Oops, duplicate name. We cannot have work unit 01 because it's already in use. Work unit 02. Very good. So now we have an object that represents our entire nested hierarchy of tag structure in the PLC. Plant area plant 01, plant area 01, work centre 01 with work units 01 and 02 inside it. So now we can deploy these objects. In fact, let's not deploy them just yet. This is another fault with this IDE. Occasionally it drops those things in places you don't want them. So these are not assigned to a host at this point. So we want to do a little trick here. Expand this tree, and now we can see in our deployment view and in our model view, in the model view, we're going to see this nested hierarchy, and this actually represents much more closely what's in the plant. The plant area, the work centre, and the individual work units. So that'll be very similar in the model view. So if we expand the model view, we see again these nested objects one underneath each other. So if we go back to our deployment view, these objects are not assigned to an app engine. So we're going to need to place them under the site in this example. So plant 01 was now dropped under site. So site is going to belong to enterprise, so we're going to drag site in the derivation view. Oh, enterprise has already been dragged under site. That was the default behavior of the empty galaxy that we used. So now that we've set these to an app engine, we can now deploy them. This should be relatively quick. Unlike deploying the Galaxy repository or the app engines themselves or the view engine, deploying the individual objects is relatively fast. Excellent. It's very important to note this success, because when there are errors, this says failure or warning, and behaviour is not always exactly what you'd expect, and it's not clear or colour highlighted to indicate that there was a failure. Okay, so if we now expand, we can see our nested objects in the deployment view. So that is how you would deploy a custom model using some inheritance. Now things start to get interesting when we add another couple of windows to our screen, namely the I/O device window and the I/O device mapping window. This is where the auto assignment comes into play. We have not defined as yet where our objects are going to get their I/O from, other than the fact that they come from that model hierarchy, but there's no definition of where the I/O itself maps physically to. So in this case, what we are going to do is expand these out completely. We're going to see that by default, the app engine and all the components underneath it were placed underneath the simulator I/O device as the default behavior of this empty galaxy. That's not really going to suit us because we're not going to use the simulator. We've actually got a PLC, and we called it bench001 with a symbolic fast scan topic. We need to undeploy these objects and move them over to the PLC that we want them to, that we want them to be reading from. So here we see warnings, not 100% of these undeployed, mostly because they had children objects and we tried to undeploy them in the incorrect order. So in this case, we are now going to redo that undeployment on the ones that failed. If we're lucky, these will undeploy cleanly now. Excellent. Undeploy. And we can undeploy the galaxy as well. You could control click and select 3 separately if you wished. Oops, wrong one. Undeploy. I'll pause for a moment. This one will take a few. Okay, our platform is completely undeployed. Now we're going to take all of these objects and place them underneath into the symbolic fast. Now in this case, this will mean I/O auto assignment is going to look to the symbolic fast topic on the bench001 I/O device for its auto mapping of tags. So in order to see that work, let's have a quick look inside here, inside our plant object. So when we left the plant in its default state, the attribute in its default state, and didn't play with the I/O mapping features, excuse me while I just close these up a little so you can read the whole screen. So inside here, we didn't change this default behavior here. So now when we've dragged this in underneath the bench001 DDE SuiteLink device and the tag and the topic name, we now have the first part of our object here and the custom attribute for it here. So all of this was auto assigned. So if we're lucky, we now have a DDE SuiteLink object that we tested with the SMC and showed the connection was working to the PLC, and now we have a DDE SuiteLink object name and a topic name that are valid, and we now have the first level of our hierarchy mapped automatically. So now when we look at one that's further down the hierarchy tree, because we dragged and dropped them on top of each other to set their position in the model, we should now have plant area 01 underneath plant 01. So this is how the nesting of these structures in the PLC is achieved by auto mapping. So if we're exceptionally lucky now, and we deploy all of these objects, we'll go to our deployment view, and I'll highlight all of these and hit the deploy button. I'll pause the video because it'll take a few minutes. In fact, scratch that. What I will do is close these in order for them to be checked back in. The red ticks disappear, and now we'll deploy them. So this will take a few seconds. I'll pause the video for it. Okay, our entire object hierarchy has just been redeployed. So we'll open this I/O device mapping window back up so we can see a little bit more of it. Now, if this is working correctly, what we should now be able to do is drag an object into here and check the runtime value is being read correctly. So validate the reference, and these will go red if it does not work, and they'll go green if it does. Okay, excellent. So this is the S95 description and the S95 name from the P01 object. So in this case, inside the PLC, off screen when you couldn't see it, I added the values P01 building 1 and P01 as the name of the object. So now if we grab something a little further down the hierarchy, this is plant area 01. So if we add this here, we see the reference that was automatically created for the source of the I/O. So it's our DDE SuiteLink object name, our symbolic fast topic name, and the entire model hierarchy to this depth for this object. So plant 01, plant area 01, and the S95 name and description that were inherited from that master object. So now if we validate these two should work. Okay, so plant 01, area 01 is the warehouse. So if we were to highlight all of these objects, hold down Shift, second click, much like all the other Windows software out there, now we see the entire list of these objects. So all of the I/O for our entire model, excuse Windows doing whatever it is that it's doing, which has stopped me being able to click on anything at all, thanks Orchestra Machine. That was paused. I cannot click. Okay, so now if we view all of the objects with auto-generated I/O, we can expand this a little bit. We can now see this entire list down here. So I'll shorten these columns up a little bit just so you can see a bit better. Expand that one. Now if we validate the data coming from these devices, we should see, our structure. Plant 01 and its name, area 01 and its name, work center 01 and its name, and so on and so forth. So these have been auto-generated, the mapping. We no longer need to maintain a list of I/O sources or map between static I/O definitions and graphic objects and so on. So let's go ahead and open up our master user-defined object. Now earlier, when I was paused, one of the things I did was create a symbol. So I created a simple graphic with very little in it, so a name and a description. So I'll open that up very briefly and show you. So in the graphic editor, we have a rectangle and two text boxes. The text box has got one animation, and it's a value display of the S95 name. So what I'll do is I'll actually make a completely separate one and show you just how that works. So let's say S95 name. Okay, so we've created that object. So I'm going to give it a name here, so that in the elements tree here on the left you can identify which one is which. Text name 2. Okay, so let's pull up an animation, and we want to add a value display from a string source. And it's going to be relative to the current object, so we want to see the current objects, so hence the me prefix, S95 name. Hit OK, hit save, and then close that. Okay, so this graphic now belongs to the user-defined master, and it will be inherited by all of the objects that inherit from that template. So despite the fact that this isn't a video about the operational management interface or OMI software, let's have a quick look. Let's have a quick look at the OMI desktop applications. So you notice when we deployed these objects, or we changed these objects, the desktop application was marked as being deployed but not the current version. So something's happened here, and it's quite an important something. The OMI suite or application is now very tightly tied to the objects that you have defined over here on the left hand side. So this change represents the change that took place when we edited one of these children objects. So let's deploy that OMI desktop application for a second and then go have a look at it. So I think one of the things that is quite exciting about this OMI product is the depth to which it integrates directly with your Orchestra and System Platform objects, and the amount of functionality that you get out of the box without having to create any special scripting or project. Okay, now that that's deployed, let's minimize this. I'll close this. And let's pull up this Wonderware application manager. Okay, so the InTouch OMI desktop application is the one that we see here. So now that that's been deployed, let's launch it and have a quick look at some of the out-of-the-box functionality. The OMI application is very much, in my opinion, under development, so I would caution heavily against investing too much into it at update 1 of 2017. It appears to be a very impressive product, and it's going to be phenomenal when it's finished, but I would urge some caution. Okay, so some out-of-the-box functionality that is particularly useful is not so much this automatically generated content, but this content. So some user navigation, login, logout stuff, some alarm severity things. Our navigation menu, which we'll look at in just a moment. And this particular feature, which won't do much in our application here because it hasn't been configured, the SCADA playback mode allows you to pick a time frame, a starting time, and a replay speed, which allows your HMI to effectively become a historical HMI that replays events that have occurred in the past at the nominated speed. So for incident investigation or for understanding problems or reviewing the actions that were taken, it's possible to replay the exact view that a SCADA operator has seen, or an InTouch OMNI application user has seen as time goes by, seeing the screen animations, the trends, and everything else go by in the nominated speed. So very, very useful feature, and probably adds a great deal of value to particularly incident investigation, where looking at a number of trend pins on the screen is of limited value, especially when trying to understand the context of the decisions that were made. But let's go back here to the navigation menu. So just before I do that, let's have one quick look. Look at our object hierarchy here, our master user defined, our plant area, work center, and work units. Now, in terms of how the model is arranged, we know that we have a site, and that contains a plant area, and a work center, and each work center, in this case, has 2 work units. So if we have a look at our OMI application, automatically generated was this navigation menu, including our site, our plant 01, plant area 01. The graphic that we created is automatically tied to the navigation menu. So we have our warehouse and our machine, our work center, and our work center components. So all of that was generated out of the box. The breadcrumb trail at the top here, the clicking events, the tying to the graphics, all of that comes as out-of-the-box functionality. So if we close this application now, and let us make a little change here, and this is where the use of an object-orientated design philosophy really pays off. Let's have a quick look at our model. If we browse to our model, we see our plant area, work center, and individual work units. Say, for example, in our work unit, in our work center, we add a new conveyor, for example, or a new section. In fact, let's go to plant areas. We add an entirely new plant area. What we might like to do is say that we've got a new plant area. Let's go work center. Let's go further down the tree. So inside our work center, going to want to create a new work center. And let's say it's going to belong to plant area 01, and it's going to be work center 03. Let's rename that object. Okay, in terms of derivation, we know our plant area belongs, our work center belongs to plant area 01. So let's change this naming structure to match this one a little bit better by changing the contained name. So we'll remove all this prefix information just to make it a little bit neater. Oops. Without the mistake, it'll work better. Let's rename it to that, so it now matches. Let's say we wish to have a work unit for that new work center. So it's going to belong to work center 3. It's going to be work unit 01. Okay. Let's say it belongs in there. Let's shift F2 and change its contained name to make it match with the rest of them. Okay, so we now have two new objects. We have a work center and it has a machine, a component underneath it, a work unit. So if we were to deploy this, we'll notice had I had the tree open, you would have noticed something. You'll notice here under the View app that the instance of our View app has changed because the model itself has changed. So if we redeploy this, remember we just created work center 3 and work unit 1. As soon as that application is deployed, we can go back to our manager and we see that it was deployed a few seconds ago. And now we can launch that application. Now, if we take our asset menu and we navigate down through the enterprise of the site, we go to plant area 01, all of a sudden we have work center 3. We should have one work unit underneath it. And because this work unit exists inside my PLC with some changing numbers in it, we see the following. Okay, well I hope that gives you a few ideas about how the OMI application could be very useful in development of your interface, but primarily that was supposed to be an introduction into how System Platform can be used to go from the definition of a DDE SuiteLink object that talks directly to your physical hardware, in this case a Siemens 1500 series PLC, through the operation integration suite and this particular driver topic port configuration, and how we take that DDE SuiteLink object created in System Platform's Orchestra IDE and then drag and drop our user-defined objects into that scan class using the IO devices and the IO device mapping window in order to automatically assign IO to our model.